Hello. Today I am going to be talking a little bit about shared memory, mutex, and pthreads in the context of operating system. These are essentially concepts that help us in multi-threaded programming. And firstly, let's talk about shared memory. Shared memory is a key concept in multi-threaded or multi-process programming. It allows multiple processes or threads to access the same region of a memory. The benefits of shared memory is that, first of all, it creates for an efficient communication. Similar to how we looked at IPCs, processes can communicate by reading or writing to shared memory. The other thing that is a benefit of shared memory is that it is faster and cheaper than IPC is. So essentially, in the context of IPCs, they can be more expensive in terms of the resources of the operating systems, whereas threads are a little cheaper to implement. Some of the challenges that come with shared memory is, firstly, without proper synchronization, shared memory access can lead to race conditions, data corruption, and the other thing that we worry about is security. Shared memory must be protected from unauthorized access. Um, let's talk about mutual exclusion, or mutex. Mutex is the name for the function. It's short for mutual exclusion. Mutual exclusion is like a synchronization primitive that ensures that only one thread can access a shared resource at a time. How mutex works is, essentially, let's look at this in a way that we have a function, and there's multiple threads that want to access that function, and that function also uh, makes changes to a variable in the shared memory region. How mutex would work is, uh, if thread number one would first request access to the mutex, if the mutex is available, the thread enters that function. Very important, you lock it. So you lock the mutual exclusion when you enter the function so that no other threads at that point can access that shared memory region. Also, for us, it will be known as the critical section. So once a thread enters the critical section, it makes sure to lock it so that no other threads can access it. Uh, Now, thread number one is already inside the critical section. Let's imagine there's another thread, thread number two, that's trying to access the critical section. Now, since the mutual exclusion is locked at that time, the thread number two will wait until the mutual exclusion becomes available. So now let's go back, look at thread number one. Thread number one in the function goes through many different processes that is user defined, finishes them. After it finishes using the critical section, it unlocks the mutex, at which point thread 2 can gain access, and then thread 2 does the same thing, locks, goes, and then unlocks it when it's done. Now, the importance of mutual exclusion in the concept of shared memory is, firstly, it prevents race conditions by ensuring exclusive access, and then it also helps us with data consistency and data integrity. Now, let's talk about pthreads. Pthreads, the P in pthreads stands for POSIX threads. Now, POSIX threads is basically a standard API for creating and managing threads in a multi-threaded program. The few things that we will need for pthreads is, firstly, thread creation, thread synchronization, and thread termination. The basic concepts of any programming is, when you have something, you create it, you use it, and for us, we have to synchronize it. And then lastly, when we're done using it, we terminate it. Now, let's go ahead and look at a code that I have written, which will help us understand the working of threads. Let's swim into the thing and look at it line by line. Um, Firstly, let's start with main. Similar to last week, because we have an ID for process, we have an ID for threads because we're gonna have multiple threads. We need to identify them. We initiate two threads, give them a process ID. Then I have two variables, amount one and amount two. These are the two things that we're gonna use to access the shared memory region, and we're gonna use them to pass into our thread function. Now this is we're initializing the mutex. So basically, we're creating a mutually exclusive space. We call that mutually exclusive space balance mutex. The second parameter that I've put null over here, this is to define the attributes of your mutual exclusion. This can be something like recursion. For us, we're going to use default attributes for this program. The next part, we create two threads, thread 1 and thread 2. The first part is we're giving the thread ID. The second part, again, this is the attributes that you can pass. The third thing is the withdraw. This is our function, which will be accessing in the mutual exclusion. And then lastly, we have the amount, which are the two arguments that we're passing. So first parameter is going to be your thread, attributes, your function, which is going to be in the critical section, and then your argument. And similarly, we have something for thread 2, and then we have thread join. Thread join, this is similar to wait PID in processes. What thread join does is it waits for the thread to finish, and then it joins the thread and deletes it. The first parameter is the thread you're waiting on. The second parameter, this is not for attributes. This is for pointing towards another thread if need be. We can talk about this a little more when we know the understanding of threads. Similarly, I have join thread. This is going to wait for thread number 2 to finish. And then lastly, we destroy our mutually exclusive space, and then we're done with our program. Now, let's look at it. Let's look at this. Once we create the thread, it's going to go to this program, withdraw. Withdraw over here takes one argument, which for us is going to be amount. It goes inside. The first thing it does is it locks the mutually exclusive space so that no other threads can access it. Then we have a function, which is if account balance is bigger than the amount, then you minus it, and then you print a statement withdrawn, and then you print out new balance. Otherwise, you just print out insufficient funds for withdrawal. And then after the variable is done accessing it, we unlock the mutually exclusive space, the critical section, so that other threads can access this area, and then we return null. This is how it will work. This over here is our shared data. Our shared data is account balance, and then we have a pthread mutex t. This is the initialization of the mutually exclusive space. We're defining it over here. Let's go ahead and run this function. Before I do that, let me put this into a little context to make it easier. Imagine you have a credit card account, and in credit card account you can have multiple authorized users. So you have one user and another user. Thread 1, let's say that's the first user. Thread 2 is the second user. Let's imagine thread 1 is the person. Thread 1 and thread 2 at two different places put their card in at the exact same time. What would happen is thread 1 would go first, or thread 2 would go first, depending on how it was accessed. Thread 1 would or person 1's transaction would go first, and then person 2's transaction would go. And because this is a credit card company that has the same limit, or you're accessing the same credit limit that you have, it's gonna subtract it from there and see if we still have need for it. or if we can still use, or the person 2 can still have money left after person 1 is done using the transaction. Let's go ahead and run this code. Again, GCCC is our compiler, dash O, create object files and linker files. Our program name is lab5.c. Let's put in a program name, let's call it bangprog. And then again, with threads, you have to pass in a flag, which is LP threads. This enables the functioning of threads in our Linux system. Let's go ahead and compile it. I don't know why I did this. Wait, I will fix it in a second. Sorry, I apologize for the delay. What it did was it deleted my file. That happened because I used the wrong flag. Let's go ahead and recompile this. Our compiler, dash O, program name, let's call it bangprog, and then our file name, lab5.c. And again, I got the flag wrong. It's not LP threads, it's LP thread, singular. Let's go ahead and compile this. We compiled it, and let's go ahead and run our bangprog. So again, let's see. What it does is, firstly, the first function accessed it and it withdrew $300 from it, and then there was a new balance. And then our second person was trying to make a transaction for $800, which at that point there was only $700 left. So the second thread, or the second person, when it accessed it, it said insufficient funds for withdrawal. Hopefully this video was helpful to in helping you understand mutual exclusion, threads, and shared memory. And I hope you have a nice day. Thank you.